This is Mr. Alexander, and today I want to talk to you about the normal distribution, at least the first part of it, and that's IB Subtopic 4.1. The normal distribution has this nice bell curve, and right in the middle of it is the mean, the median, and the mode. We use this mu to represent the mean. And from the mean to the first inflection point, that's called a standard deviation, which is the symbol sigma. So that's mean plus sigma and mean minus sigma. And in between one standard deviation of the mean, that represents 68% of the data underneath that curve. Between two standard deviations, that represents 95% of the data. And between three standard deviations, between three standard deviations is 99% of the data of the distribution. So this is what it looks like, and we can use this curve to answer questions if we know things are normally distributed. For instance, the heights of 200 lilies are normally distributed with a mean of 40 and a standard deviation of 3. Part A, we're supposed to sketch a normal distribution to show this. So you start with that nice bell curve, put the mean in there of 40, and then 1, 2, 3 standard deviations, 1, 2, 3 standard deviations. They tell me the standard deviation is 3, so it's going to go up by 3 every time, and down by 3 every time. I've got a curve here, and now that I know some things about this curve, I can start answering questions about it, like the probability that a lily has a height less than 37 centimeters. I like to start with another picture. So here's my mean of 40, here's 37, and less than is to the left, so that's all this stuff right here. In my calculator, I'm going to use second vars 2 to do this calculation. Second vars 2. My lower bound is 37. My upper bound is 40. My mean is 40. Let's start over. My mean is 40. My upper bound is actually 37. Because you're going left to right. The lowest number underneath here, since the normal distribution is asymptotic to the x-axis here, the point all the way over here is negative infinity, which we represent in the calculator as negative 1 E99. If you're looking for that E, it's just second comma. My standard deviation is 3, so when I paste this in, it's going to spit out a probability for me. So the probability of getting a height less than 37 is about 1.9, which is about 15.9%. Part B, we'll do that one over here. It says find the probability that a lily has a height between 37 and 46. So draw yourself a little curve. Here's 40. Here's 37. Here's 46. And we want to be right in between there. So I want the probability that it's between, the height is between 37 and 46. And I'm going to use my calculator to help me out with that. So I'm going to go second vars 2. My lower bound now is 37, my upper bound is 46. My mean and my standard deviation are the same. I'm going to paste that in, I'm going to hit enter. It's about 81.9%. Or as a proportion, 0.819. That was part C. Last one's part D. We want the probability that the expected number of lilies with a height greater than 43. Well, the probability of getting a height greater than 43, we can use the calculator to find that. So second vars 2, 43 is the upper bound, and positive infinity is the upper. So 43 is the lower bound, because we're talking greater now. So if I was to show you on this curve, it'd be like 43 is right here, and we want all the stuff to the right, because greater than. So that's positive infinity all the way over here. Mean and standard deviation are the same. The probability of that happening is about 0.159. Now they told us me in the problem that there are 200 lilies, so the expected value of getting a height greater than 43 is just that 0.159 times 200, which is 31.73. So in this case I'd accept the answer 31 or 32, depending on how you look at that. Let's do one or two more of these. Make sure you got it understood here. I'm just going to pick one. Here we go. Let's just do some of these on the back. The scores in a physics test follow a normal distribution with a mean of 70, standard deviation of 8. Find the percentage of students, of students who scored between 55 and 80. So if I draw a really rough bell curve here, my mean is 70, and I want between 55 and 80. This stuff. So I want the probability that a student scored between 55, I'm going to use percent sign, and 80. Calculator can help me with that. Second var is 2. The lower is 55, the upper is 80. My mean is 70, and my standard deviation is 8. Paste it in, hit enter. It's about 0.864. If they want it as a percentage, that's 86.4%, which would be the answer there. Calculate the expected number of students who scored more than an 85. So here's your 70, here's your 85. I want the stuff to the right, more than. So the probability of that happening, second var is 2. 85, the upper bound is infinity, so second 1e, second comma, 99, mean of 70, standard deviation of 8. The probability of that happening is 0.0304. 0.0304. So to get the expected value, let's draw an arrow. That's that stuff. That's that proportion. To get the expected value of getting a number of students more than 85, so let's say students is greater than, or I guess percentage greater than 85, you take the proportion, you multiply it by the number of students, which they said is 30, and I'm just going to multiply them. So this isn't quite 1, so the answer here would be 0 or 1 student. So either one person, we'd expect one person to be able to do it, or nobody to do it. If it's less than 1, then you choose. Alright, I'm feeling particularly giving this morning, so I'm going to do the one paper 2 question I put on here. This was on the IB exam in 2014, and it's kind of challenging. Let's talk about it. A group of candidates sat a chemistry examination and a physics examination. Candidates' marks in the chemistry exam are normally distributed with a mean of 60, standard deviation of 12. Draw a diagram. Love to. Here we go. X-axis, bell curve. There's your mean of 60. There's your standard deviation of 12. There's your picture. Write down the probability that a randomly chosen candidate who sat the examination scores at most 60. So let's say the probability that the candidate scored, let's use M for marks, at most 60, so that'd be less than or equal to 60. Calculator's going to tell me that. Second distribution, normal CDF, so -1 e to the 99, 60, mean of 60, and standard deviation of 12. Paste that thing. It's about 0.5. Now that makes sense because 60 is the mean, so if I was to shade this curve, I'd be shading everything to the left of 60, and that's half the curve, so that makes sense. It's about 50%. Alright. So we've got a student who scored 80 marks in a chemistry exam. Find the probability that a randomly chosen candidate who sat the chemistry exam scored more than that student. So if I drew a curve, there's your 60, and there's your 80. We want the stuff to the right, scored more than an 80. So the probability of getting marks greater than 80, let's find out. Second var is 2, 80 is the lower bound, positive infinity is the upper bound, and it's about a 4.0478, which is about 4.78% chance of that happening. Pretty small chance. Less than 5% of people were able to do that. Alright, last two parts here, then we'll be done. The candidate marks in physics exam are normally distributed with a mean of 63, standard deviation of 10. Same student scored 80 marks in physics. Find the probability that a randomly chosen candidate who sat the physics exam scored less this time. Okay, so let's check it out. We got our normal distribution. We got our 60. Oh, sorry, the mean now is 63 actually. 63. There's your 80. We want everything to the left of that. So the probability that they got marks less than 80, we will go to the calculator to ask the calculator that. Second var is 2. The lower bound is negative infinity. The upper bound is 80. The mean now is 63. Standard deviation is 10. So the probability of that happening is 0.955. Just about 95.5% of students scored less than that student. Determine whether that student's physics mark compared to the other candidates is better than her mark in chemistry. Give a reason for your answer. Well, I'm looking at these percents here. And so in chem, 4.78% of students scored better than this student. In physics, 95.5% scored worse. So if I subtract that from 1, multiply it by 100, that means that only 4.46% of students scored better than her on physics, which means that physics is the better score because less people were able to get a better score than her. So physics was the better mark. And that's an example of how they'll test the normal distribution on paper 2. Okay, that's all I've got for today. Thanks for watching. Next time we'll do inverse normal calculations. See you then.